around the world, let's say, there's climate change, and the historic design of dams was designed for a certain climate. Right? And that climate is changing. The extremes are changing. One city's wastewater discharge ends up downstream is someone's drinking water, right? So there has to be a lot of cooperation. Nature has evolved billions of years, and we've come along, let's say, in the last couple of hundred years and tried to modify it. But nature often knows best. So if we can emulate sort of natural type solutions, they tend to, given the long history, work fairly well. And really, as a global water community, and not just a water community, we need to work hard to make sure that there's access to safe water around the world.
Namaskar and welcome to another episode of the Professor Mahesh Podcast, your resource to help you make informed career decisions. As we like to say, this is your future simplified. This podcast is brought to you by IITM Global, an initiative of the Office of Global Engagement at IIT Madras. IITM Global is our platform to take everything IIT Madras, our courses, our teaching, our research, our startups, our philosophy broadly, to the global audience. Learn more about their efforts in the link below in the description. As you watch these episodes, please subscribe and turn on notifications so you are informed of all future episodes that come online as well. Among the many things that keeps life going are the two most important elements that we take for granted, air and water. We're going to talk about one of those two elements today, water. Fresh water. If I were to start by saying fresh water is in short supply in the world today, it may come as a surprise to some of you. Some of you may already be experiencing it. To help us unravel all of the engineering behind good quality fresh water supply, I have Professor Denis M from the University of New South Wales in Australia. Welcome, Denis.
Thank you for having me. Yes, it's lovely to be here.
Tell us a little bit about this whole field of water resource management embedded in the discipline of civil engineering. Is that where you started? Was that your original undergrad training?
That is right. Yes, I did my first year. So about the career journey, I did my first year as a mechanical engineer.
Okay.
And then I was inspired to work more in the environment, more get out as opposed to sort of in the built space. So I switched to civil and environmental engineering with a real focus on water and the environment. And since then, I did my undergraduate at the University of Ottawa in Canada, and then a master's degree at Clarkson University in Northern New York in the US, and then my PhD at the University of Michigan. And I worked in consulting for a few years, or a couple of years in between my master's and PhD. So my whole career would have been in civil and environmental engineering.
What sort of problems came your way in that couple of years consulting?
Well, I was mainly working in wastewater.
Okay.
Yeah, and designing it was in Toronto, and outside of Toronto, there was a significant expansion of the city. And there was a recognition that the existing wastewater treatment plant would exceed demand capacity in the next 5-10 years. So they had to develop a master plan. So that's primarily what I did. I did also some other smaller jobs, which was really quite interesting. One I do remember fondly was on the side of the highways in North America. There are comfort stations or rest stops. And I was involved in designing a small wastewater treatment plant there, which was really interesting because it was very tangible.
Sure.
And quite interesting in that regard. Yeah,
very interesting. And these are usually standalone wastewater treatment plants.
That's
They're
right.
not linked to a sewer network.
Well, they could be either one. Depends on proximity to a wastewater treatment plant. So if you're near a city or a small town, perhaps there is one. But if it's tens of kilometers away, it makes sense to treat nearby.
Water resource management as a discipline is embedded in civil engineering.
That's right.
In most universities.
That's
out
right.
there.
Yeah.
But this discipline of water resource management itself is a fairly broad discipline.
Incredibly broad. Yeah.
So let's unpack that for the audience.
Yeah.
Okay, what are all the different elements of water resource management when we say water resource?
Sure. Well, I'm probably not going to do it justice because it is quite broad. So at the University of New South Wales, we have almost a small but separate campus or lab where there's and it's beside a dam or reservoir. So we have large scale hydraulics type experiments,
Okay.
and we do a lot of dam engineering there. And in Australia, around the world, let's say, there's climate change, and the historic design of dams was designed for a certain climate, right? And that climate has changed, and the extremes are changing. So we now we're looking at redesigning many of the dams in Australia.
Mm-hmm.
So we do large scale physical modeling. In 2011, in Brisbane, which is a major city in Australia, there was significant flooding. And at that time, there's a series of dams in Brisbane, in series, and Brisbane flooded, and it cost billions of dollars of damage. And there was a recognition at that time that to go through or following that incident, to go through and look at all the dams. So we have the Somerset Dam right now at the University of New South Wales, a large scale physical model. So it's let's say 10 meters by 10 meters, and looking at the topography, looking at the flow across it, and energy dissipation. Really, what absolutely has to not happen, is a dam cannot fail. Right?
Yeah.
It cannot fail.
Sure.
So we need to make sure we get that right. So when water comes over a dam structure, there could be scour or erosion on the downstream end.
Sure.
And that could lead to the dam failures. So we do a lot of work around that. So that's one area. I could get carried away. That's just one area. So another big area we have is hydrology, and broad scale hydrology.
Mm-hmm.
And that might be around rainfall. We do a lot of rainfall prediction, and then so because of rainfall, then that obviously leads to precipitation and surface water and groundwater runoff and flooding potentially. So how do we predict that? How do we develop mitigation measures? How do we plan for it? How do we have early warning systems? We also would have strengths in coastal engineering.
Mm-hmm.
So let's say in ports, we would do a lot of work broadly in port design, shoreline erosion. Chennai, I haven't been to here in Chennai, the waterfront, but I do. Hopefully tomorrow I'll get there. But you could have shoreline erosion, and there's a lot of population right beside these by the shorelines, and specifically. Potentially, I'm not sure here in Chennai, but let's say in the Pacific, as an example, there's many of the islands could be susceptible to, let's say, storm and storm surges and inundation. So how do we control for that? How do we mitigate? How do we have early warning systems? And especially now with the change in climate, we also I also do a lot of work in let's say urban hydrology.
Mm-hmm.
Nature-based solutions, let's say green roofs, green walls. And that's really a recognition of nature. Nature has evolved billions of years, and we've come along, let's say in the last couple of hundred years, and tried to modify it. But nature often knows best. So if we can emulate sort of natural type solutions, they tend to, given the long history, work fairly well. And there's significant benefits, I would suggest, to the urban environment if we can do that. In terms of water quality, there's historically and growing urban intensification, increasing pressures on our precious water resources that we use to drink and for daily activities. Because of that, we need to develop ways to not to clean the water that we're disposing out into the environment and wastewater, and also purify the water that we are drinking, and ensure that the number of people who don't have access to safe water decreases around the world, and that is a global challenge. Mm-hmm. That's a sort of a broad range, I think.
Wonderful. So we started with dam engineering, then then precipitation and water resource management, groundwater, subsurface and supersurface water, rainfall. Then there is urban water delivery systems, urban water management systems. All of these are sort of integral to the idea of just getting clean water delivered to a home, be it in a rural community or in an urban environment. Let's just sort of walk with the water. Okay, like when I open my tap at home, we're all blessed that clean water flows out. Help us understand the engineering that goes, all the way from where the water is collected from rainfall to where it shows up in our tap.
Well, water could come from a variety of sources. Let's say, and you could have in Sydney, we have a desalination plant in Australia, so you could use seawater. Now that isn't, or ocean marine water. That isn't a preference. It is quite costly because you have to remove a lot of salt, and it's not efficient in terms of the amount of clean water you get per amount of water treated is actually not great. And
these are mostly reverse osmosis systems.
Yes.
Is that the gold standard still in large?
Yeah. So there's a large scale membrane technologies, which are very energy intensive and expensive. So I'm getting slightly off track here, but we would always, in terms of water engineers, there's an increasing thought around the carbon footprint associated with it, and the carbon footprint associated with desalination is quite large. So that's desalination. There's also fresh surface water. So let's say rivers, lakes. In Sydney, we have a large number of large reservoirs that we would use, and certainly around the world. And typically, oftentimes, you'd really want to make sure that they're pristine and protected to the extent possible.
Mm-hmm.
And then there's groundwater.
So there's some engineering around protecting that a lake you need protected is protected.
Yes. So there might be an exclusion zone. Activities would be restricted. What you can do in there. Sometimes there's no human activity would be allowed. You can't fish. You can't swim. Nothing. You can't even go near it. Of course, let's say in major river systems, that's impossible because the river flows from city to city, from town to town, from country to country even.
Yeah.
So one city's wastewater discharge ends up downstream is someone's drinking water, right? So there has to be a lot of cooperation. Groundwater is another very important source of water around the world, and different areas have different amounts of groundwater available, and that typically is a great water resource as well if managed correctly. So depending on which source you use, that necessitates different treatments. So if it's a groundwater, oftentimes it's actually quite clean, and we have to do relatively little in terms of treatment. It depends, of course, but often that's a really nice source if you have it, and there's enough water there. Surface water from lakes and rivers oftentimes requires a little bit more treatment because there could be bacteria pathogens in the water, and those will make us sick or could kill us. So there's treatment methods that you would use, disinfection methods oftentimes to clean that up. And then we did talk about seawater as well, which has salt, and salt you have to remove as well. So that's even something else that would need to be removed. So after that, water would go into, let's say, a distribution system, and those are under pressure. And you might have it actually gets quite complicated and quite potentially interesting because it can be so complex. It could be, let's say, in a major city like Chennai or Sydney, there's a number of different water treatment plants, and they all feed one network. And all those networks it's all interconnected, and you could have towers to control the pressure, water pressure. You always want pressure. So how that's all managed becomes quite interesting. It has to be managed correctly, and then obviously the types of treatment as well. There could be, for example, scaling of pipes, and there's all kinds of operational issues that you could encounter before for the proper management before it ultimately gets to your home.
In many cities in India, water supply is still intermittent. So you get fresh water in a pipe from, say, 7 in the morning till 9 in the morning, and then again from 5 in the evening till 7 in the evening. So the whole problem of managing the supply is that much more intense because you don't have continuous pressurized water in the supply source. Is this does this require a different type of engineering, or is it the usual urban resource management that would suffice?
Well, I suppose, and not being an expert on the exact situation, you would maybe be concerned about incursion of, if it's not pressurized, incursion of water outside of the pipe. Pipes are never 100%. There might be some leakage. So if water gets in from the groundwater or surface water in nearby sewers, that could cause problem. So then you might design for extra disinfection in the pipe, or some kind of disinfection. So you have a more of a residual, long-term residual. So if anything does get in, it's not going to be problematic potentially. So that those,
Sure. You alluded to bacterial pollutants that need to be removed, but you have worked on man-made pollutants that contaminate our freshwater sources. Tell us a little bit about what are the top three culprits globally in terms of man-made pollutants that seem to have made their way into freshwater.
Well, unfortunately, there's a wide range, but it's really which ones are of significant concern. So, of course, we could have man-made pollutants. We could have personal care products, pharmaceuticals that we ingest, and for good reason. We if we're sick, but what we don't want is for them to persist in the environment and to modify the environment. Which could be of a concern. Another one is PFAS. It's an emerging contaminant, perm polyfluoroalkyl substances, and that's a forever chemical, and that's pervasive in waters around the world largely, and certainly in urban waters, and it has been at relatively low concentrations. People are concerned about linkages with negative health effects, for example, some cancers. Yes, there's a wide range, unfortunately.
Sure. Let's talk about the challenges, be it research or just plain engineering challenges in this community globally. Let's start with the biggest of them all, climate change. That seems to be changing, the way we consume, or we are able to manage water. Let's tell us a little bit about exactly, what is under the hood when we say climate change is affecting.
Sure. Well, climate change. Maybe climate extremes would be a really big problem. So the norm and the amount of precipitation, for example, and actually heat, it does change how we haven't designed our systems, and we haven't adapted yet as a society to what those extremes are. So, for example, if you have more flooding. For example, you might design an acceptable bridge, or might be designed to a 1 in 100 year flood, where now that flooding event might occur every 10 years, right? So it's much more frequent. Or floodplains. People were, let's say, historically in places that I've lived, allowed to build homes in somewhere that might have a 1 in 100 year flood. But now if that happens every 10 years, that becomes much harder to manage, and we need a lot of infrastructure to deal with that. And also there could be more emergency services required associated with that. A big one, I said earlier, is in terms of dams, and let's say how to manage a dam. So a dam for water, sometimes if you want a dam, you might want it for flood control. So if it's for flood control, you want the dam empty. But if it's for water, for drinking water, you always want it full. You want that water. So that's inherently a conflict in terms of where it is. And then projecting that what the weather's going to be like in the foreseeable future, such that you can adequately manage that water level, becomes a challenge. If there's an extreme, if you have it near full and you're thinking historically it's not going to rain that much, but then there's an extreme event come through, and then there's overtopping of a dam potential failure. Those would be all sort of issues that we would have to deal with.
And apart from climate change, in terms of water resource engineering, what are some exciting problems that young men and women can look forward to contributing to?
Well, it's I suppose the design for I would think to ensure people can live safely is for me quite.
I
quite
think
exciting.
as the rest of our industry evolves, the plethora of man-made pollutants that could creep into water is becoming richer, and so the technologies to remove them would need to be newer technologies need to be developed as well.
Yeah.
To bring in to make future fresh water fresh in that sense. How many all of the different sub-disciplines that we alluded to, starting with dam engineering all the way to urban water supply, typically in an undergrad program, in an undergrad civil engineering program, all of these would be covered in maybe one or two classes.
Mm-hmm.
So let's take the next step. And typically, if one would want to specialize in any of these, one would need to do a master's level degree. Mm-hmm. Tell us a little bit about what are the different flavors of master's degrees globally that you may be aware of in this space of water resource management broadly.
Well, and you are right that there's so many sort of different areas that you could look at. For example, water quality. You could do a master's degree almost exclusively in water quality, and that you might focus on drinking water treatment, so that when you drink water yourself, or for example wastewater treatment, which would be entirely different type in terms of the scope, maybe the technologies that you would use. And then also water in the natural environment. Algal blooms are really, really big, really an emerging problem, sometimes associated with climate change. And so that's natural water. It's not water that it could be related to activities that we use. If we discharge wastewater into a surface water and we change the chemistry around, we could cause algal blooms. Of course, they could naturally occur as well. So that's one area. Of course, we could also have in terms of urban hydrology. It could be in terms of the designing for the sewer and the drinking water systems in an urban area, the local streams, culverts, all that kind of the built environment we could also work in. And then also potentially, of course, hydrology. So precipitation, rainfall, forecasting is a real challenge. Groundwater would be a big area as well. So then it could be from numerical modeling to going out and doing field work and measuring water levels and the chemistry associated with it, which is quite interesting. Do that in remote locations. Surface water as well. They could do a lot of work in surface water, management of surface water, moving water from one reservoir to another. And I did mention earlier coastal engineering as well. Yes, there's a wide range of aspects.
And there's an army of water resource engineers that are all working to sort of manage these resources so we have clean water to consume and use.
That's right.
That's wonderful. I think among the many master's programs, are there also programs that specialize in urban water management, or is that just getting too specialized at the master's level?
Well, you would have probably some courses. Some universities would have distinct areas of strength. So absolutely, you could probably almost exclusively go in and take, let's say you're doing a master's degree, you might take 7 courses. You could almost take 7 courses all around that urban water space.
So let's talk of careers downstream of a potential master's degree in a water resources related discipline. Where would these graduates go? What are the different job opportunities out there globally that, say, in Australia or Canada that you may be aware of?
There are so many, and it could go from, let's say, the mining sector as an example.
Oh, wow.
We haven't talked about that yet, but mines, water management in mines is a very, very big deal. If you're building a big mine, let's say in Australia, or in India as well, and you're below the water table, then you need to extract mineral resources below the water table. You have to do something with that water, and that water oftentimes is not. The water quality has potentially deteriorated. So you've got a water management issue, and you've also got potentially a water quality issue. So what are you going to do with it? So that's one area, as an example.
Sure.
You could also work in consultancies. In Australia, that would be very common. Working for a number of different, let's say, clients. And it could be different water utilities, different cities for ensuring safe drinking water or treating wastewater. one could also work in the ports area. So one has to design a port. It has to what are the waves, the wave climate and things like that, such that boats have to have a quiescent place to berth.
Mm-hmm.
So how do we design for that? So there's a wide range of areas. You could also potentially work in the electrical hydropower industry as well. Pumped hydro is so in terms of in Australia, it's sort of people kind of talk about it, moving water around in different times of day. So when energy is cheap, when there's lots of let's say in the middle of the night, if you have you've stored, you might move water up into a reservoir, and then in the morning at peak energy time, consumption times, you might generate power generation. So there's quite a wide range of exciting careers that you could get into.
And water quality assurance or water quality management,
yes,
is another span of careers.
Absolutely, yes. So it could be in terms of drinking water treatment, wastewater treatment, looking at in the natural or in the environment as well, ensuring that we have we're not detrimentally degrading the environmental the water quality. Certainly is as I mentioned mines, but it also could be more broad than that as well.
And along the conversation, you sort of said things like, either know or measure how much water is in different reservoirs. Let's talk. I mean, it's not an easy problem to just estimate how much water is in a given lake. Mm-hmm. What are the different technologies that people use to come up with these estimates? Supersurface or subsurface. What are the different technologies that are now available?
Well, certainly it's interdisciplinary. So let's say in a lake or reservoir, you would maybe get the bathymetry. So you'd maybe try to figure out how deep the lake is. You might use drones, satellites. We use a lot of satellites these days. Especially there's water resources in remote locations, and we need to know them as well. So satellites, people would use satellites as an example. We would also do an awful lot of modeling. So we'd use computer models to predict, and let's say groundwater, because you can't see groundwater.
Yeah.
So you would have ideas of the depth of water. You might be able to measure if you have some wells. But then what is below the ground? What is it? Is it sand? Is it clay? Is it rock? You might use some interdisciplinary. You might use some geophysical or some other kind of methods, work with other disciplines to figure out what it looks like, and then maybe develop a model for that. And it could be a very small scale model, or it could be, let's say, tens of or hundreds of kilometers scale model as well.
Mm-hmm. And so all of this data is typically used to estimate water availability. And one of the other sort of phenomena you alluded to, rainfall.
Yeah.
Prediction of rainfall. Yeah. You said foreseeable future.
Yeah.
What's a typical horizon? What are we able to do? What's the gold standard out there?
Well, it really I guess it depends on what you're going to use that prediction for. So, for example, if you and I talk about dams a lot, but this is an easy example. If you're operating a dam and you want to know what's the right level in that dam for the next week or month, you want to have that scale of prediction. Sometimes you would make longer term predictions. Let's say in Australia, we're subject to droughts, so it could be very wet, it could be very dry. So they would come up with predictions for let's say we're coming into summer now. What's the summer going to be like? Is it going to be a dry summer? And if it's a dry summer, they might more actively plan for fires. And how are we going to plan for that? How are we going to manage it? Such that we limit the impacts to humans, but maybe also the environment. Yeah.
And it appears that all of these measurements, be it from rainfall to groundwater, throw out a bunch of data. Has data science always been sort of integral to water resource or management studies, or is that now an emerging area for research?
Well, it always has been, but even more so now, AI, machine learning is really becoming an important tool that we're using to make predictions. Because there are two things. One, we've got these incredible data science tools, but also we've got all kinds of data. More and more, we're able to measure things and collect a lot of data. And because of that, because we're collecting a lot of data, we can then use that to calibrate our models, train our models, and make predictions into the future.
And let's talk a little bit about startups. This seems to be if I was to don the hat of a young engineering graduate, this field seems too daunting to get into.
Yeah.
Is that close to reality? If not, help us dispel that myth.
Well, I would say no, absolutely not. It's exciting field. There's all kinds of advancements that we do need. We talked about forecasting. We need to be able to do that better, and that is evolving. Water treatment, for sure. We need to, because of the advent and the recognition of these emerging contaminants. We need to develop improved methods to treat them and cost-effective methods to treat them. So there's so many opportunities for new technologies, new innovations in the field.
Going back to traditional jobs, where are the jobs in this whole sector on water resource management? Or we talked the whole breadth of opportunities.
Yeah.
But are there opportunities? Of course, there are opportunities in the government,
yes,
in local governments and state governments. But are there also opportunities in the private sector? You talked about mining.
Mining, absolutely. Mining, we do work in Australia in the mines, and they really it's a short-term and a long-term problem for them, or in terms of the bottom line. They really have to manage the water in the near term, because they've got all this kind of water that they're extracting, that they're pumping out, and they have to discharge it. And to move water around is very expensive. So then that's how do you do it? How do you do it cost effectively? And then there's also impacts to the environment. So if you move water from here and you move it 5-10 kilometers downstream, that's going to, and you change the flow dynamic, that's going to impact the natural environment. And what are the impacts? How do we do that safely, as an example? And in the long term, let's say here or in Australia or any mine, if you dig a big hole in the ground and you extract all kinds of ore from the ground, in the long term, if there's a big hole, that's gonna potentially fill up with water. And even after mine closure, what are you going to do with that water? It's let's say in many parts of Australia where there are mines, they're arid zones, so there's no lakes. So if you make a big hole in the ground and there's a big lake there, that changes around the water balance, and you're going to have all kinds of evaporation from that, which is not a natural occurrence. So that's going to change, and but then there's costs associated with filling back in that water with materials as well. So all these things are real challenges. So that's one example. Private industry, you might also work in a consultancy, so designing for a drinking water treatment plants. Someone has to come up with the design, and then also in terms of technologies, the young water engineers can develop new technologies. Work for the industries that actually develop, let's say, the new membranes, the new ion exchange resins, for example. Yeah. So there's all kinds.
There's a lot of room, I believe, there, because some of the technologies that we use commercially are fairly old already.
That's right. Yeah.
So I'm sure they're waiting for some disruption.
Yeah.
For somebody to come along and disrupt that space. What are some research ideas that are being explored? Let's start with membranes and water purification, and then we'll go.
Sure. Well, with membranes are so we would consider them a high-end technology. They are costly, and they don't last forever. So you would have fouling. So you have after a certain amount of time, the membrane gets clogged. and then you need more pressure to push water through the membrane, and that's expensive. So how do you control for that fouling, and then how do you control, let's say, the membrane with time will degrade. So how do you design the polymer such that it has a longer effective lifespan? Those would be some examples in the membrane space that people would be working on.
And research in terms of groundwater management, sensing maybe. If I was to go to a water resources conference, help us, give us a sneak preview of some of the ideas that I may hear at a conference like that are being sort of experimented with in a lab.
Yeah, well, quite a range. Let's say people would think about managed aquifer recharge for a number of reasons. But let's say in areas where you have monsoon, so you have a very rainy season and a dry season, you might want to take that rainwater and put it into the ground and store it for in 3-4 months when there's not as much water around, to pump it back out. How do you do that? How do you do that effectively? How do you manage it? And what you really, we're get a bit technical, that you have to make sure that the waters are compatible. If you take rainwater and inject it into the ground, you don't want it to cause all kinds of precipitation, or such that when, let's say, you pump the water back out, there's all kinds of iron, or the color is all funny, or arsenic has come out. Those kind of things would be real challenges that one would consider. Other ideas, maybe satellites in terms of groundwater. How do you estimate groundwater resources and maybe even groundwater quality using satellite images?
Let's talk a little bit about the regulatory, professions around here.
Yeah.
I'm sure there's an army of people who are qualified water resource engineers who are there to sort of ensure that other people are doing their job, right? Are those careers that you see? For example, would there be somebody certifying that the water coming into the city is clean?
Absolutely. Certainly in Canada, where I started my career, but around the world, there is governmental agencies that's their job. Unfortunately, in Canada, it was a small issue, but that's not. I shouldn't say small because it was tragic. But around 2000, a number of people died because the water treatment, or the water utility was not adequately treating the water, and really didn't. The people working, the personnel didn't understand water treatment, which was really bad. So at that point, there's a recognition that the systems had to change, the oversight had to change. And in water treatment, we would want a multiple barrier concept. So you'd want, if water quality fails one, there's many other barriers in place, such that ultimately, and oftentimes there's 7. For all 7 to fail all at once and have poor water quality, it would be, that wouldn't happen. That should never ever happen, but it did happen. So how do we ensure that all the measures are in place? So people would go around and have regular inspections of the treatment systems, and then they would be on site and just do visual and physical inspections, but then also look at the reporting and look at the data and make sure that everything is in order to help ensure that the water at the tap is of the quality that we expect.
Let's zoom out a little bit and talk about globally the availability of fresh water and what are the problems people encounter in their own day-to-day lives. Clearly, there's a very inequitable distribution of fresh water globally. And the UN has made it one of their sustainable development goals to have access to clean water. What can we do to sort of help solve the problem? Let's start with the highest level thoughts that the community is pursuing to solve this at the global scale. And maybe we'll look at some local solutions.
Sure. Well, on a global scale, often there is, you obviously need access to fresh water, but then what you want is fresh water of adequate quality for human consumption, and that's really the big issue globally. In that it's most of the population doesn't have access to that water. by and large, we would have technologies, cost-effective technologies, to treat that water and to ensure that water is upgraded. It may not be perfect, but of much better quality. And really, as a global water community, and not just a water community, we need to work to make sure that and work hard to make sure that there's access to safe water around the world. Yeah.
And broadly, do you say access to fresh water is also linked to high population densities, or are there areas of high population density but poor access to water? I mean, how do you have communities naturally come up around sources of fresh water?
Well, I'm not a global population expert, but I would say largely yes. But there's certainly, there's people, let's say in some parts of the world, maybe in some parts like Dubai or places like that are largely on the ocean, and they're somewhat inhospitable environments. But we are making a decision to live there, or even let's say Las Vegas in the
Sure.
US as well. These places that aren't really naturally suited for us to live at massive scale. But in many other parts of the world, historically, up until maybe 100 years ago, it wouldn't have made sense to have major cities around there, because we just simply wouldn't have had any kind of technology to treat it. But now we do have that. But this question, does it make sense? Because it is very energy intensive to have people living there.
The reason I brought that up is really, is the technology, we seem to be moving into spaces, exactly as you said, which were inhospitable even 100 years ago, unthinkable.
Yeah.
Today, it's technology that is enabling us to build these large, massive communities.
Right.
And that's completely man-made. And so we're wondering how reliable it is, to have a large community fully and wholly and solely dependent on technology. That seems to be I mean, we seem to be betting too much on this one horse. So that's the only reason I brought that up. I think let's...
I'll just say one quick thing on that though. But if someone likes to have technology and wants to do leading edge things, those are the places that need it. Now we could have a debate about whether or not, from a climate change type carbon footprint perspective, it makes sense. But that's where the leading edge technologies might go.
Sure.
Yeah.
Like in India, the Gangetic Plains there's plenty of freshwater supply there.
Yeah.
So it made natural sense that was the densest part of India.
Yeah.
Right. And today there are areas that are still sparsely populated, and freshwater supply is proportionately sparse as well.
Yeah.
So I think continuing on from the zoomed out view, we talked of climate change, and we talked of how climate change is sort of amplifying these extremes. Extreme drought as well as extreme rainfall. Mm-hmm. We talked of what extreme rainfall does. Tell us a little bit about what extreme drought events could do. Those, in my mind, seem to, just from a general thinking perspective, they may percolate deeper into people's lives because it affects food supply far more than, water supply too as well, right? We didn't, actually in this whole conversation, we didn't talk of one of the main uses of freshwater, agriculture.
Yeah.
Right? Maybe we should spend a couple of minutes just talking about the use of water in agriculture, particularly in India, which is a large rice growing country. Right? How do we... So it's the same fresh water from a dam that's managed and brought into fields.
Yeah.
Is that the standard globally, or are there better ways of managing water for agriculture?
Well, it could be surface water, it could also be groundwater, and that allocation of that resource is a real challenge, and there is using it for agriculture, but also the natural environment to function needs water as well. So there's environmental allocations as well that need to be balanced. And in Australia, it's a massive issue in terms of water allocations, and farmers want to have the water that they require or they would like for agricultural purposes. But sometimes that's the negative long-term detriment to the environment, and we're continually drawing down our aquifers, for example, but also in our rivers. In the U.S., for example, the Colorado River, which it flows from the U.S. into Mexico. Sometimes it's almost negligible flows across the border, and those are really a challenge because of over-allocation of resources and major movement because of dams of water from one basin to another. Yeah, so it is a challenge.
If a young student got excited from this conversation and said, "Let me go learn a little more," what would be a good conference to attend?
Yeah.
What are some conferences where all the best water resource people congregate every year or periodically?
Well, there's a number of them. I'm going to the American Geophysical Union conference it's in Louisiana this year, in New Orleans in December. There's also an equivalent European Geophysical Union that's held annually in April in Vienna. There's also conferences, let's say the International Association of Hydrologists, IAH, around the world. So there'll be a number of really peak body. It just depends on the subdiscipline. But I think let's say for the AGU conference, it'll be over 20,000 people there.
Wow.
Yeah.
20,000.
Yeah.
So
not all focused on water, but let's say half of them.
So this is not an insignificant discipline. Of course, water is an integral element of what we need to survive, but we don't seem to be giving it its due respect. I'll in a moment say what I mean. We pay a price for every little gadget or device we use in our lives. The amount of money we pay to buy our mobile phone, versus the amount of money we would end up paying for water. Clearly I can survive without a mobile phone.
Yeah.
Let this be our little closing thought. Why is it that water is not respected?
Well, it could be because it's more of a communal asset, or it's everybody's, and so our impact to water and negative is a small, but there's a lot of people in the world. So if we all have a tiny negative impact on it, it adds up. So perhaps that diffuse type reason might be the reason as well, and also we take it for granted. It's always been there.
Yeah, so, I think that second thing, that we take it for granted.
Yeah,
seems. I mean, we need to be careful that it doesn't come back to bite us.
That's right. Absolutely. Yeah.
So, your closing thoughts for a young student: why should they really get into this discipline? What is the big calling here?
Well, there's just so many grand challenges out there that associated with water and human population and the environment, and we really need a lot of great minds, because there are increasing challenges, and we can't take it for granted. So it's a tremendously lively and rich career, I would suggest.
Well, thank you, Denis, for coming and helping us unpack this. I mean, an area we take for granted, but there's so much engineering that goes into sort of making this happen for all of us. Thank you again very much.
My pleasure. Coming. Thank you. Thank you very much.
This has been another episode of the Professor Mahesh Podcast, your resource to help you make informed career decisions. I hope this conversation on careers related to water, from dams to urban water supply, would excite you, and some of you would choose to go into that discipline. Until we meet again, be well, do good, and keep in touch. Goodbye.